in the back there for setting up this event space. This is probably, I feel so excited that I'm on a pedestal, right? I feel so empowered to do whatever. This is great. We have Matt today talking about IPv6. A little bit dense, but a little bit fun as well.
Yeah.
I think I tweeted today, I was like, I know it's annoying. I know you don't want to do it. I know there's other priorities, but IPv6 is coming, and you should really understand how the internet talks to itself. So this has been a lot of like in the making, getting people to come forth and give ideas to talk over the next few months. Next month we have Brian from GitLab. We're still working on planning that out. He's actually works from home in Traverse City. So he's going to be coming. I don't know, we're going to be hosting that yet. More details forthcoming there. A couple quick announcements, just because I'm in the DevOps Days realm and helping plan that. We have signups open for that, and you can go to our website, conference.devopsdetroit.org, and find out all the details for signing up. I think it's a reduced rate right now as well, which is exciting, not that it's a ton of money. The other thing is that we have CFPs open for speakers. So if any of you find people who, a lot of you have given talks before at Orchestructure, or want to drive on at Orchestructure, we have, I think, 2 or 3 more months open this year for people who are still interested in talking about something DevOps related. Please come forward, talk to myself, Bob, George, or Jeff, the co-organizers who do most of the work here. So we'll get you planned out. There are bathrooms. There's 2 bathrooms that way, and there's one near the back. There's also more pizza, etc., left over. At the end of Matt's presentation, we'll do a announcement time for a few announcements. I know that some people have some things they want to share. So I think without further ado, Matt on IPv6.
Yeah, thanks for the intro, Mario. So hey, I'm Matt Lair. Today we're going to be talking about IPv6. So a little bit about me. I'm an engineer at Fastly, but today's talk is all about my personal experiences and not related to Fastly. You can find me on GitHub, Twitter, website, pretty much everything as MD Lair. And the contents of this talk, as well as my others, is available on GitHub, MD Lair Talks. So today we're going to talk about IPv6. We're going to introduce some of the fundamental concepts of v6, why it's important, why you should care. I'm going to explain some of the differences between v6 and v4. And finally, we're going to demonstrate, aka show on slides, because I'm not brave enough to configure my router from 90 miles away. We're going to show how to set up IPv6 at home on a Ubiquiti Edge router device. So for example, if you're running Comcast or Charter at home, should be just fine. AT&T, Fios, etc. Best of luck. So let's start by talking about IPv6. How many folks in the audience are using IPv6 at home right now? More than I would have expected. That's really great. So typically when I say something like this, it's not very many, and I'm like, oh, we'll get there. But honestly, it's actually more people than you might think. So at least according to Google on their services, as of roughly a month ago, 22% of their traffic was coming in over native IPv6. And this is extremely cool. And as you'll see over the past 5 or 6 years, there's been a lot more adoption in the IPv6 space. Pretty cool stuff. But IPv6 itself, yes? Why is there a fluctuation? Is that jumping up and down? Yeah, so my understanding, I believe I read something on either their website or some forum that said this is people actually going home on the weekends and using the internet at home, because typically your corporate network might not have v6 as much. There's a band, so it's increasing in the traffic. Yeah, yeah, I believe so.
S&P 500.
Yeah. Yep.
It's like does that have 0% for 6 to 4? Because do they stop using it? Is that what this is showing?
Yes, I believe so. Yes, there was a little bit of tunneling traffic up until mid 2018. There's a tiny little bump, but generally the providers are all doing native these days.
There's more IPv6.
Yeah, pretty cool. Yeah, so IPv6 though is more than just a bigger address space. So of course, the thing that people think about is the gigantic long 128-bit IPv6 address. But realistically, you split this into 2, because 64 of those bits are for networks and 64 bits are for hosts. And something else that's really cool about IPv6 is that your IPv6 enabled interfaces will almost always have multiple addresses. So we're kind of used to this v4 world where you have 1 address per interface, but this no longer holds for IPv6. There are several different types of addresses. And in fact, it's not uncommon for your interface to have 3, 5, even more. So for example, some of the different types include global unicast. You can think of this like your public IPv6 address. unicast local, and this is kind of like your RFC 1918 or private IP space. You can use this to run services at home with addresses that never change in case your prefix does. And there's also link local addresses. And these are really interesting. They're kind of a different beast altogether. But the basic idea is link local is truly link local. So the addresses actually are only unique per link. But these are a mandatory part of the IPv6 specification, and lots of things in the protocol use these to communicate, such as neighbor discovery, which we'll go into later. So of course, if we're talking about IPv6, we've got to give some kind of quote about the size of the IPv6 address space. So I found this quote on Reddit and I really liked it. You can give every millimeter from one side of the universe to the opposite side of the universe in a straight line about 3.6 billion IPv6 addresses. And this is just like crazy huge. Like in theory, the space is effectively infinite, but I guess we'll see, right? You know, with the advent of things like nanobots, everything suddenly having its own public IPv6 address, we'll see. But right now, such a small portion of the space is actually allocated for use that it's effectively infinite. So there's a few different ways you can assign IPv6 addresses. Some of the most common ones, aside from static IP, which still exists, you have the modified EUI64 format. And effectively, you take your MAC address, split it in two, flip a couple of bits, and then append a prefix and a couple of digits in the middle. And you end up with this IPv6 address that is a computed version of your MAC address. So this is nice, and devices will typically use this by default, and it's good for servers and such, but the problem is with this, is that if you were to keep making outbound connections to different servers with this address, they could do the calculation in reverse and get your MAC address, and suddenly you're able to be tracked from all the different websites you visit. So this isn't great. So as a result, there's also the IPv6 privacy extensions, and you can have temporary addresses. So for example, this big long thing here, this is just a random address I took when I was making these slides off one of the devices on my network. There's no rhyme or reason to it whatsoever. The address probably expired a month ago. But what's cool about IPv6 is your interfaces are continuously generating new addresses. So like I said, it's not uncommon for them to have 3 or 5 addresses, and they use those temporary addresses for outbound connections, but you can continue to use the EUI64 for your inbound, so that way your firewalls and such can have stable rules. But I think one of the coolest things about IPv6 is prefix delegation. So for example, your ISP, even a residential one like Spectrum, which I have, can route an entire IPv6 prefix to your house. So maybe if you're paying a bunch of money to your ISP, you're going to get a handful of static IPv4 addresses. Most of us just have one, and then we have network address translation and all this nastiness. But I'm running with Spectrum. They give me a /56 as a residential customer, meaning I have 256 different networks of 2 to the 64 addresses available to me at my house. I'm using like 2 VLANs, so I've got 254 different networks I can use if I'd like. And what's crazy is that businesses or ISPs get even bigger allocations like /48 or /32. As a result of this, you don't need network address translation with IPv6. Everything can have its own globally routable IPv6 address, or even many of them, because there's just so much space. So if you're going to be working with IPv6, a lot of your favorite shell utilities like curl and such will have a -6 flag to force IPv6 mode. I really like this website for testing your v6 configuration called IPv6-test.com. There are several out there, but I think this one's pretty comprehensive and good. And of course, ping is every networker's favorite troubleshooting utility. So there's this IPv6 address, 2600::, and this expands out to 2600 and a whole bunch of trailing zeros. And this is an IP owned by Sprint. So thanks, Sprint, for giving us a very memorable and short ping target in case your DNS is broken, which happens from time to time. So now you're curious. How do I actually obtain one of these IPv6 prefixes at home for myself? To do that, you use DHCPv6 prefix delegation. So what this is this uses DHCPv6 to request a prefix assignment from your ISP. In addition to your router getting its own IPv6, single IPv6 address from your ISP, it can also request a prefix assignment. As a result of this, your ISP will see this, and now any traffic within that prefix is going to be sent to your router. It is now your responsibility to handle everything in that /56 or what have you. So for example, the one I've linked here on the screen, this is my /56 at my house. What's also cool about this is that while my public IPv4 address has changed from time to time, I've had this same prefix for a couple of years now, no problem. So I'm guessing that Spectrum at least probably does not change the prefixes because they have so much space, but you never know. So this is pretty cool. And this is a really popular method these days for ISPs like Spectrum to enable dual stack, aka IPv4 plus IPv6 network access. And we're going to be living in a dual stack world for quite some time, probably forever, realistically. So let's talk about how this actually works. So let's start with a home network, and it's set up for IPv4 only at the moment. We have the internet, we have our ISP's router, and then we have our home router on our property, and we have devices behind that, such as a PC, a phone, a server, etc. If we try and ping the IPv6 internet, nothing happens. So we have IPv4. It's kind of like the horse and buggy, kind of old school, still works just fine, perfectly pleasant, I guess, but we can do a lot better these days. So to start, we're going to use DHCP-v6 prefix delegation to get a prefix for our house. Our home router is going to send a DHCP-v6 request to get IPv6 connectivity from our ISP. But it's also going to specify the prefix delegation option so it can actually receive a prefix from the ISP as well. So first, the IPv6 or the ISP router is going to assign us an IPv6 address, let's just call it A, to our home router's WAN wide area network interface. So if the ISP or whoever else wants to reach the router directly, it now has a single address for doing so. But in addition, it will also delegate and route the prefix, let's call it P/56, to our home router. So this P/56 is just, for example, the prefix I have at my house. From here on, whenever the ISP router sees traffic that matches that IPv6 prefix, it's going to send that to your home router. Traffic comes in from the internet bound for some address, let's call it B, that resides within that prefix. The ISP router consults its routing tables, it sees this, and it forwards it on to your home router, and from there, it's your responsibility. So now that we actually have the prefix assigned to our router, how do we distribute those addresses to devices on our network? And this is where we introduce the IPv6 Neighbor Discovery Protocol, or NDP. So NDP in its base form is kind of like the IPv6 version of ARP, but it has some special tricks. So it also runs on top of ICMPv6 using those link local addresses we talked about earlier, instead of some weird bespoke Ethernet kind of thing, which is what ARP is. So of course, you can ask a network neighbor for its MAC address using its IP address, just like ARP. So two of my devices are communicating. Who's got FD00::1? This is a convenience address I assigned to my router because it's really easy, short, memorable. So my router says, yes, I have that address. I live at this MAC address. You can update your neighbor tables and talk to me directly. But I think the best part about neighbor discovery and what's really killer about IPv6 is you don't actually have to run DHCP-v6 at home at all to configure globally routable IPv6 addresses on your network. You can do this using stateless address auto configuration, or SLAAC, via the neighbor discovery protocol. Lots of acronyms in networking, right? So the clients on your network can also fetch additional configuration from DHCP-v6 if you want. There's various methods for doing that. Or if you're in a more tightly controlled network, you could do DHCP-v6 only. But for our home networks, SLAAC is just fine. So let's show how this actually works. We're back to our home network, and our home router has now been delegated an IPv6 prefix by the ISP router. Again, P/56. So from here, the home router is going to start to do some interesting things. It's going to create a single network within the 56 called P/64, so chunking off one of those 256 available subnets. It's also going to assign an IPv6 address, let's call it B, to its LAN interface. So for example, this address B ends with ::1, so this is just a static IP I've assigned for convenience as well. Easy to see on your network what your router actually is. So where things get interesting is your devices, if they want to speak to the IPv6 internet, they can send a multicast router solicitation to basically discover IPv6 routers on the network, find their default route. So the router solicitation basically states, hey, I'm looking for connectivity. Are there any IPv6 routers out there? Your router will now see this, and as a result, it will send a multicast router advertisement in response with the prefix P/64. And the router advertisement has a bunch of information, including, if you should use this router as your default route, and etc. But what we really care about here is, yes, I am an IPv6 router. I have this prefix I am advertising, this P/64. You can use SLAAC to compute your own addresses and assign them yourself, and you can consider your addresses valid for the next 24 hours. As a result of seeing this, every single device on your network that's capable of doing this can compute and assign one or more IPv6 addresses from that prefix. And as you'll see here, these are using the modified EUI64 format. The giveaway is the FFFE in the middle of the bolded parts, kind of hard to see. But now all of my devices have IPv6. So now every device on our home LAN that speaks v6 can use its globally routable IPv6 address to speak to the IPv6 internet as a whole. So sure, we can have our IPv4, the horse and buggy, but why do we want IPv4 only when we can have IPv6? That super fast, shiny F1 car. So if you're interested in playing with neighbor discovery, I've actually done some experiments with Go. You can check out mdlayer.com for an index, or just come talk to me afterward. So how do I actually set this up at home on real equipment?
So before you go on,
Yeah.
what are the advantages of IPv6 in your mind versus IPv4 besides the enormous number of addresses and simultaneous addresses?
Yeah, I just think it's really interesting that every device is capable of having its own public, globally routable IPv6 address. You don't have to worry about network address translation. You can actually do like firewalling like properly instead of doing like weird port forwards to run services on different ports and stuff like that. So for example, you can run SSH on multiple different machines instead of port forwarding different ports to different machines or running like a bastion host. There's various advantages. But I think those are the coolest ones, like for home uses, is being able to, connect to the whole internet and also like learn how this stuff works, because ultimately this is the direction the internet is moving.
You're doing it the way you just showed?
With V6, no. So you could, yes. So your router will send router advertisements if you configure SLAAC. And you do not need to run DHCP v6. As far as I know, for v4, there's no equivalent of this.
Okay.
But yes, good.
Would you recommend someone that doesn't have V6 capabilities through their ISP to use something like Tunnel Broker by Hurricane Electric to get IPv6, or do you recommend just leave?
Yeah, so I've tried a couple of times before. Way back in the day, I tried Hurricane Electric, probably 2008, 2009 with, my Linksys router with hacked up firmware and all this stuff. I didn't have a super good experience back then. I don't know what it's like today. I could be totally wrong. It could be great. And also, a couple of years ago, Charter actually didn't have native dual stack. They had their own 6RD. Yeah, 6RD was the tunneling thing. And there was one tunnel server or in Minnesota or something. And suddenly my Debian package updates aren't working because the V6 tunnel is down. And it was just kind of a hassle. So I would encourage you to try it out. I have no idea who your ISP is or what the situation is like. Give it a shot. But that being said, tell your ISP that it's time to get on board, because lots of ISPs are doing this. Comcast has this rolled out everywhere. Spectrum has it rolled out everywhere, as far as I know. So
It still sucks, but
yeah, yeah. Yeah. So let's set up IPv6 on the home network. So today we're going to talk about Ubiquiti Edge Router devices, and in particular the Edge Router Lite. So this is the router I run at my house. This is super duper nice for home use cases. So for example, if you're just kind of a power user, you want to spend about 100 to 120 bucks on a router, this is a great device. It's a full feature Linux machine. It's powerful. It can run a gigabit connection, no problem. I've got the gigabit service with Spectrum. It can do IPv6. You can run experiments with BGP or other things. It's pretty awesome. Give it a shot. So this device features a command line interface as well as a web UI, but unfortunately, at least as of today, not all of the IPv6 functionality is actually available in the web UI. So we've got to dig into the command line. So the CLI interface has a config tree sort of interface that may be familiar with folks who've messed with routers before, but it's also just a full Linux machine underneath. So you can run commands like uname to see your kernel, W to see who's logged into the router. I've actually had some success cross-compiling Go binaries for MIF64 Linux and running them on my router, which is pretty cool. So to actually enter the configuration tree, you type configure, and this will open up this editing menu. And from here, you basically traverse the tree by typing in different key values. So you'll notice it's kind of like this JSON-esque format. So if I do show system offload, this traverses into the system and offload trees and displays all of those values. And this is effectively how the entire device's configuration is laid out. So to actually set up IPv6 at home, we're going to need to configure a few things. The first step is an IPv6 firewall. You can no longer rely on NAT, port forwarding, etc. as your firewall. It was never really meant to be a proper firewall in the first place, and NAT is not security. But with V6, this is especially crucial because all of your devices have globally routable IPv6 addresses. So if you don't firewall them, people could print whatever they want to your printer or various other things, We're also going to set up DHCP v6 prefix delegation on our WAN so we can get a prefix assignment from our ISP. And we're going to set up SLAAC on our LAN to actually distribute those addresses as well as the default route. So the slides are going to be based on my current router configuration. So ETH0 is my LAN or local area network facing interface. ETH1 is my WAN or wide area network. And I linked a blog post here by Bradley Heilbronn. I may have used this a couple of years ago, but it's been some time. So just in case, thanks, Bradley. Appreciate it. So step one, we need to create a couple of firewalls. We need a firewall for the inbound traffic to the router itself. In the Ubiquiti terminology, this is the local firewall. And we also need a firewall for the traffic that's passing through the router to the LAN, the in firewall. So when traffic arrives for our router, we need to do a few things. And some of these steps are going to be repeated for the inbound firewall, so I won't repeat them. we need to make sure we allow established and related state. So for example, if you're sending TCP requests out to the network, you need to make sure that the TCP responses can actually traverse back through the firewall. That's important. We need to make sure that we drop invalid state. So something funny like a TCP ACK on a closed connection doesn't really make sense. Make sure you drop it, keep it off your network. We want to make sure we actually allow ICMPv6 to the router. There have been lots of folks in the past who have recommended blanket blocking ICMP. You can't really do that as much for v6. Things like ping won't work, NDP router advertisements from your ISP that give you your default route, path MTU discovery, and lots of other things. Consider locking down parts of it if you really need to, but I just allow ICMPv6 in general. It's just convenient. You also need to make sure that your ISP's DHCPv6 server can talk to the DHCPv6 client running on your router. So to do this, we're going to set up a firewall. So if we do set firewall IPv6 name WAN6 local, we're going to create a firewall entry for IPv6. We type edit with the same command, and that will essentially traverse us into that point in the tree so we can save some keystrokes from now on. By default, we're going to drop traffic. You can choose to reject if you'd like. I think drop is the same default. Set a description so you remember what this is later on when you're messing with this, a couple of years later. And the way the firewall rules work is they are numeric, and they go in order of ascending order. So rule 10, rule 20, rule 30, whatever. You can use every single number you want. I like to space them in increments of 10 in case I want to add rules before or after different places later on. So the first rule, we make sure that we accept our established and related traffic. So we just set the state flags that we'd like to match on to enable, no problem. Second rule, dropping invalid state. Again, just matching a single state flag, and we're going to drop it by default. For our third rule, we're going to make sure that we just allow ICMPv6. Again, if you wanted to make sure that you only allowed certain like ICMPv6 codes or something like that, you could do that here. And also we need to make sure that our ISP's DHCPv6 server, which is UDP port 547, can talk to the DHCPv6 client, which is UDP port 546. Networking is like so many acronyms, right? So then we type up to go up one level in the firewall, and we're going to repeat essentially for our in firewall as well. So three of the rules are exactly the same related to the state and the ICMPv6. But here, for traffic that's bound for our LAN subnet, we can also individually allow services to reach our LAN. So for example, if you're running a server at home or a desktop or whatever else, and you want to have SSH or HTTP, this is where you do that. So this first slide is essentially exactly the same, but we're creating a different firewall chain. Same couple of rules to start. Same ICMPv6 rule, but now you can add your rules for your services. So for example, SSH runs on TCP port 22. So we specify a destination of my IPv6 address, big long thing, the TCP port 22. And then now we jump back to the top of the configuration tree because we want to actually apply the firewall. To do so, we run set interfaces Ethernet eth1. Remember, my WAN facing interface. We apply the in firewall, WAN6 in. We apply the local firewall, WAN6 local. Yes?
So in rule 40, it is some IPv6 address inside the brackets. That's what you're saying?
Yes. Yeah, I thought about putting an actual address in there, but it would have like word wrapped and yeah. Yep.
So how do you pick that?
Yeah, I was going to say in your previous example, you said the IPv6 address is valid for 30 minutes or less.
Yeah, so
what do you do?
so I guess now that I think about it, I kind of skipped around here because at this point, like you're configuring the firewall, but you don't necessarily have v6 connectivity yet. So you don't actually know what your address is going to be like. So that's a good catch. Like I said, I based this on my current configuration. I've already got this set up. Yes, so this v6 address would come once your router has the prefix delegated and it starts handing out addresses with SLAAC. This, for example, would be either a statically configured IPv6 address within the prefix that you chose. So you take your prefix and you assign your own static address. Or in my case, I use the modified EUI64 address. So computed MAC address equivalent. Yes. So take the prefix, take the MAC address, do the computation, put it in there. So yes, good call. I should have come back to this later on. Yeah, so now the firewall is applied. We type commit. This is going to save the changes in memory. So it's going to actually apply things, but it's not going to persist to disk. You type save to save to disk. Yes?
Can you use the link local address in there?
No, because the link local address cannot be reached from outside the link even. So it can't be, especially can't be reached from the internet. So you would actually put your globally routable IPv6 address in here or several of them.
Right. I'm just trying to get around my prefix changes and now.
Yeah, so the interesting thing for me, at least, like I said, my prefix has never changed. But what I do, and I'm actually going to talk about this a little bit later, is I also run a unicast local prefix. So I have FD00::. and all of my internal services that are v6 run on those addresses. So I have those addresses assigned to every machine. I have DNS set up so that, my machine.internal.ipv6 whatever actually use those addresses. So that way, in case my prefix ever does change, my internal addressing scheme does not have to change. Because in addition to having those globally routable addresses, I also essentially had the v6 equivalent of the private IP addresses. Yeah. Anything else? Okay, cool. Yep, so our configuration is saved at this point. So now we actually do the DHCPv6 prefix delegation. So our router needs to request an IPv6 prefix from our ISP. We're going to specify that we want a prefix of, say, /56. Generally, /56 seems to be what most of them are going with. I've also seen /60 or /64, but you don't want that because that gives you one network, not what you want. And with businesses, you can get an even bigger allocation, like /48. We're going to sub that out the first /64 for our use. Again, SLAAC and such work with a /64. So we're going to take just one of those 256 different networks. We're going to create a convenience address, which is going to be P, our prefix, ::1. This is a static IP assignment. Again, makes it easy to see which one's your router. And we're also going to specify that we should use SLAAC to actually distribute those addresses. This is really easy in Ubiquiti gear. And also, I really do recommend ignoring your ISP's DNS servers from DHCPv6. I don't know about all of you, but I've generally had some pretty bad experiences with my ISP, like making fake websites, fake DNS responses and stuff like that. So use Google DNS or something like that. You'll have a better experience. Yeah, I don't know. Yeah. So in order to actually set up prefix delegation, this is actually a bit less verbose. We just edit the configuration for ETH1. We create a new prefix delegation, PD0. We specify a prefix length of 56. The first subnet, 0. Host address of ::1. This is going to be the static IP assignment. Specify we want to use SLAAC to actually distribute the addresses. And then specify we want to ignore our ISP's DNS servers. Jump back to the top of the tree, commit, apply to memory, save it to disk.
Where's the prefix in that?
The prefix is going to come from your ISP. So you don't actually know the prefix at this point, but it's going to, for example, the prefix ID and the host address are going to take that prefix and essentially compute it into what they're doing.
So
Yeah.
how are you setting the DNS servers at? Is that the GUI then?
That's a different configuration. Yeah, I didn't discuss it here, but yeah, there are various ways you can do it. I've actually done it like 3 or 4 different times now, but I'm happy to share my Ubiquiti configs later on, or at least like slightly redacted versions. But yeah, just come talk to me afterward. It'll be fine. Cool. So at this point, in theory, we've got everything configured. It should just work. So we're going to check the interface status on the router itself, make sure things are okay. And we're also going to ping the IPv6 internet for the first time. So if we do show interfaces, this is this little special Ubiquiti command. It will show you the interfaces and their IPs. So for example, you'll see my public v4 address as well as my private v4 address, as well as the ETH1. That's going to be the individual IPv6 address that my ISP gave me for my router using DHCPv6. But then I'm also advertising my ::1, my prefix /64 on my ETH0. So that's going to be my LAN-facing interface. That's where the router advertisements are coming from. You'll also see here I have the FD00::1. That's the unicast local thing I just talked about. So for example, for running IPv6 internal services, that's what I use. And as we can see, if we run ping 6, because the Ubiquiti device actually requires you to use ping 6 instead of ping for v6 addresses, it seems to work just fine. Step 4, verify that our IPv6 connectivity got through our router into our actual devices themselves. So now we want to verify that we're seeing router advertisements reach our devices. We want to ping the IPv6 internet and also open a test in our browser, make sure things work. So I actually wrote this tool called NDP. This is a Go tool I wrote. Basically, you type RS, it's going to send a router solicitation out on the network, wait for a router advertisement, and then print out all the parameters for it. Pretty cool. As it turns out, there's a Debian package called rdisk6 that does basically the same thing. I didn't know that at the time, so I wrote my own version, right? Pretty cool. I've actually used this for troubleshooting a couple of times. It's nice. But as you'll see here in the router advertisement, it's advertising 2 prefixes. We've got my globally routable prefix, the /64, which was chunked off of my /56, as well as my unicast local prefix, FD00::/64. And as we can see, we can ping the IPv6 internet, so things seem a-okay. If I open my IPv6 test, this is nice because it'll run a few different tests, showing your v4, your v6, the method you're connected. making sure that you can reach v4 DNS to get v6 records and vice versa and other things like that. So this is all cool, but this is Orchestructure. We want to talk about clusters and Kubernetes and all this crazy stuff, right? So let's take our IPv6 network a step further. And this is pretty cool, but there are some caveats to this approach. I think this would be a pretty fun thing to try in a lab, but there are probably better ways to do it with like real routing protocols, right? So let's say, for example, we have a larger network. We're going to call it the lab network. And let's say we've been delegated a prefix P/48 by our ISP's router. /48 means you now have 65,536. Is that not by one? It might be 5,035. I don't know. Anyway, it doesn't matter. You have a ton of different IPv6 networks, like a crazy amount. You've got your lab router, and you've got it connected to racks of servers. And each of those racks of servers has a top-of-rack device in it as well. So essentially, we can do the same thing our ISP is doing and delegate our own prefixes as well. So we take our /48, and we can use DHCP-v6 prefix delegation to delegate and route individual /56s to each of those top-of-rack devices. So now, every top-of-rack has its own 56. We can go a step further. Every top-of-rack can now also use DHCP-v6 prefix delegation to delegate and route an individual /64 to every single server. So now one of these servers has as many addresses as my entire LAN. But why would you want that? This is where things get really cool. So your server, for example, you could run some kind of like virtual router software. You could use SLAAC to actually assign individual, globally routable IPv6 addresses to every single container, virtual machine, whatever you want on that server from that /64. You don't need NAT. You don't need an overlay network. You don't need any of that stuff. This is just pure networking. So I think this is really cool. If you actually wanted to do this in like a production environment, you probably wouldn't want to do it this way, because the problem is here, if you want to actually migrate the virtual machine to, say, a different server, suddenly it no longer is capable of using that address. So you'd want to use a real routing protocol to do this. But in theory, this would work just fine. I think it'd be pretty fun to try. So sure, you can have your one IPv4 address for your house or your lab or whatever you want. And like, that's fine, I guess. But it's kind of like the horse and buggy. It's a bit antiquated. But why would you want that when you can have an almost infinite supply of super fast F1 car IPv6 addresses? That's it. Thank you very much. That's what I saw. I actually just asked in the channel the other day, and like people were like, still working on it. But
It is a priority.
I'm excited. Go ahead. Yes.
So from I'm not knowledgeable very much about this, but I'm used to having machines hiding behind a VPN.
Yep.
And accessing that way. So if you've got a globally routable address, if you don't set up your firewall properly, then there's anybody from anywhere can access your machine, right?
Precisely.
So
Yes. Yeah.
That makes me a little nervous.
I have a related question.
How do you think about that?
Yeah. So the interesting thing is, like, essentially that was that's like always been a concern, because like if you're, for example, if your router has its publicly routable IPv4 address and you've got no firewall on that, you're going to have the same problem. Like somebody can SSH into your router or hit the web UI or whatever else. So effectively, like the problem is kind of the same. The scale is just a little bit different, because like in the case of v4, like people have used things like network address translation and private IPs for a long time to kind of hide things. But realistically, like it's kind of like a poor man's firewall anyway. So you should just have a proper firewall. I mean, that's just kind of what it comes down to. It's definitely more.
Your stuff is what you're.
Yeah. It's a tricky thing, but ultimately, like, it is no more or less secure than v4. It's just a different kind of way of thinking about it, because it's not port forwarding anymore. It's not NAT. It's setting up an actual firewall and allowing individual services on individual IPs versus forwarding this port to this machine and stuff like that.
So is there still a use for VPN situation?
Oh yeah, I mean, I think VPNs are still useful for everything they're useful for now. Possibly, making it appear like you're in a different country or whatever else. I understand people are doing some pretty cool stuff with V6 and VPNs. I actually haven't tried, but like in theory, you could have like an entire network behind a VPN using like a /64, stuff like that. So could be pretty cool. Yes.
So, sort of related to that, because my ISP doesn't have IPv6.
Yep.
So I would assume then that the IPv6 native providers, like they're locking down that router, also probably has a built-in firewall. Like they're not setting these up. So like my mom's printer or whatever. I'm assuming.
So I would assume so. So I actually haven't bought a device. Well, I haven't used my ISP's devices in a long time, but like my Ubiquity kit, for example, like I set up my own firewall, but I would hope that when we get to the point where ISPs are issuing equipment with IPv6 turned on by default, it would have everything firewalled except for, ICMP and like TCP responses, like the first 3 rules I talked about essentially. And I would expect it, those rules to essentially always be present.
So I think it actually, the way that the routers work is it blocks everything by default regardless, but it doesn't use SLAAC for assigning addresses. It uses v6 DHCP.
Really?
Yeah.
Interesting.
So that way it takes care of not having to allow in ICMP.
Interesting.
So you're still using the IPv6 private IPs?
Yeah.
You did not rely at all on like IP tables on your local server, on like just individual servers and dissed out that config?
Well, I don't think it matters on the local server because at the end of the day, your router is still needed.
What was that question?
Some paranoid people would put IP tables on every single server they ever touch, and it's just a standard config.
Yeah.
And would you still do that?
I mean, so I guess it's worth noting, like I'm running this at home. So it's like I use my router as my firewall. I don't bother with IP tables on individual machines because I know that my router configuration I think it's easier to keep the configuration and get it right in one place than doing it on every machine. Perhaps if you have some kind of configuration management system, or potentially if you're exposing, lots of machines to the internet, then it might be a different story. But for my home network, just do the firewall. I just want to clarify one point. You mentioned like neighbor discovery. So like the router advertisements, for example, would come from your ISP to your router, but those are using link local, so that would not actually traverse through the router. So it would terminate at the router, but then your router would send its own.
The router has its own v6 DHCP server.
I just think that's interesting because like I don't know, like I believe you, but like I think it's interesting because like it seems like SLAAC would be easier just in general.
So a lot of them use, have you ever heard of RAD?
Yeah.
RAD?
Yeah.
So a lot of them use RAD or SLAAC.
Yeah, exactly. Yeah.
Yeah. But the ones that I'm talking about specifically are like the Comcast, like crash Xfinity router. They essentially just use a DHCP 6 server to allocate addresses.
That's just really interesting because for example, there's some kind of Android maintainer who is famously against DHCP v6 to the point where Android does not support DHCP v6. The only method it supports is static or SLAAC. So as a result, like if you've got some lockdown corporate DHCP v6 only network, you can't use Android phones because they just won't do it. They don't think it's the right way to do it. I would tend to agree, although I would not hold such an extreme view. But I think for home, SLAAC really is the best way. I don't know why you'd want to run DHCP v6. Maybe, I mean, you can do it for like, so for example, I mentioned there is like the hybrid mode. So for example, you could specify a flag in your router advertisements that says you can get more configuration from a DHCP v6 server. And then that client will see that and then ask for things like NTP and whatever else. But actually, SLAAC has a couple of options. For example, like SLAAC can now issue recursive DNS servers. It could not do that in the first draft. So if you wanted to issue your own IPv6 DNS, you had to use DHCP v6. That is no longer the case. That's been supported for ages. I actually had a slide about that, but I omitted it because I thought it was getting a little far off in the weeds.
So the only other thing with that is PXG booting.
Yes.
You definitely need DHCP /1.
Yes.
Yeah. You're still on TFTP.
Yeah, but you still need to use like v6 DHCP in order to do that.
But what I think is interesting though is that like there's no theoretical reason that they couldn't add a couple of neighbor discovery options that would do that.
Yep.
Like I was thinking about that too because like I run Pixie at home. I was like, why can't? I mean, maybe there are. Maybe they're just not widely supported. I would guess that the
So I'm gonna stop it here just for some final announcements. Matt will be hanging around and drinking afterwards as well. I think. So, you can catch him and get the real truth about it. I agree. The last word. Xfinity routers are terrible. Do not use home equipment if you can avoid it. Lights in my face. Actually, any announcements? If you have an announcement that you want to share with the group, just go ahead and stand up.
So, my name's Clayton. I work at Psychic now, which is like a industrial IoT kind of company. We make little batteryless sensors that can go anywhere, and we're in need of a data platform engineer. You would be pretty senior. I think you'd be like the second software person in Ann Arbor because I'm the first. Everyone else is in like Charlottesville and Santa Clara. So talk to me if you want to know more about that.
Awesome.
They have a
Anything
Slack
else?
channel that you might want to add.
It's in there.
Oh, okay.
Yeah. Yeah, actually, if you've not heard of our Slack channel, we have a hashtag Orchestructure on the Maidenade2 Slack network, which is run, I don't even remember, a couple duo people and some others run that network. If you go to orchestructure.io/Slack, it will direct you to where you, I think there's still a fun Heroku app that you put your email on and click to get an invite. So, couple other, actually, anyone else? Any other announcements? Things going on in Ann Arbor area, et cetera? Cool. Couple minor things. The Orchestructure workshop is well underway. We are a go for June 8th, so put in your calendars from 11 to 3 with doors opening at around 10 o'clock. We're going to do similar format to last year, so 4 independent sessions and kind of 2 tracks with a magical lunch, of course. Like I said, June 8th, put in your calendars. More details forthcoming. Similar topics to last year with a little bit of Kubernetes containers, also introducing developer workflow and service mesh. I think we might have someone who knows something about service mesh and has talked about it before, doing a kind of interactive demo as well. So if you want to learn about those things or have questions or any comments, things that you want to see, please let one of us know. Come in the chat and talk to us and PM me as much as you want. Also, one last thing, just because I work in Detroit, one of my cohorts that I work with has started this night of meetups, and it's happening right now. It's the last Wednesday of every month at 6 o'clock. He brings together all of the kind of local tech meetup groups in Detroit. And there's a Kubernetes, there's a Node, there's security, there's Lambdas and functions. There's all these very focused groups out in Detroit. And he brings them together for kind of this night of meetups. And I'll send details about this to the group via comments. But it's a really cool event. He's getting over 100 people. Food is obviously served. Just a lot of great networking going on. And there's 2 or 3 presentations that he does throughout the night. From 6 to 9, I think it is. So it's a really cool event. It's happening, I believe, Grand Circus and maybe one other place that he hops to. I think Bamboo Detroit also hosts there as well. Duo's got some space in Bamboo Detroit. So it's a really cool event if you're interested in just meeting other people. Don't skip Orchestructure though, please don't. But we will not be having a June meeting because of the workshop. So the last Wednesday in June would be a great time to go. Some more details on all that forthcoming very soon. Like I said, Downstage Detroit, open for sign up, and if you want to be a speaker. If you have any questions about that or anything else, talk to myself. I can direct you or help you out. So thank you very much for coming tonight. Let's give Matt a round of applause.